Okay, folks, so I made a YouTube video the other day on root locus with zeros. And so what I want to do is I want to show you that you can actually do the same root locus plot in Matlab. This assumes that you have the control system toolbox in Matlab and you have to pay for it. I have a companion film in Python where you can run the root locus just by downloading the control system toolbox. In order to test to make sure you have the control system toolbox, just type in TF into Matlab. And if it throws an error, it means you don't have it. And if it just gives you an empty transfer function, then it means you have it. So what we're going to do is we're going to build this transfer function here, s plus 3, s squared, s plus 10. I want to build this in steps. So what I want to do is I actually want to make the plant just 1 over s squared. So what I'm going to do, I'm going to make g, I want to change folder, okay? So there's my g, it's just 1 over s squared. And then in order to make a root locus, all you need to do is just type in r locus g. And what will pop up, if we wait, my computer is, there we go. Anything? Ah, it popped up over here. So I got to bring it, there you go. So here's my root locus. And so basically there's 2 poles at the origin. And so if I increase k, they just shoot off to plus or minus infinity, right? It's an even number of poles on this side, right? 0. And then over here, there's 2 to the right. So that's also even. And so there's none on the real axis. And then you have 2 asymptotes, 180 over 2, right? Sum of the poles minus sum of the zeros is 2 minus 0, which is 2. So 180 over 2 is 90. So you have a pole at 9, you have an asymptote at 90 and minus 90. And there are your zeros there, or sorry, your asymptotes there. If we then add a compensator, and so if we go to the YouTube video and I look, I've got a compensator of 1 over s plus 10. So if I do transfer function 1 over s plus 10, and then instead of doing r locus g, I'm going to drop a new figure down and do r locus c times g. And so I'm going to cascade those blocks together and essentially augment the plant. And what I'm left with is actually this transfer function here. And so now I've got a pole here at minus 10, and I've got 2 poles here at the origin. So if you think about the number of asymptotes, I still have 3 asymptotes because I have no zeros. And so now I've got 180 over 3, which is positive 60, and then 360 over 3, which is 120. So I've got 60, 180, 300 degrees, and 300 is the same as minus 60. So this configuration is actually unstable. And so in order to fix that, you need to add a lead lag compensator. And so that is making a lead lag compensator is adding that s plus 3 over s plus 10 so that you have a 0 and a pole. And so if you look at, if I drop another figure down and I do r locus of c2 times g now, so now if we look, so here's my lead lag compensator. It's s plus 3, s plus 10, right? And so I have a pole and a 0. If I look at this root locus, I actually get something completely different. So I get this chart here. And so in this case, right, I've got 2 poles at the origin, but I have a 0 here that sort of brings this pole in, and it causes these poles to sort of shoot over. And if I go back to my YouTube video, you can see that I went through the entire hand calc and I actually got exactly the same thing there, which means that this is, you can kind of look at it both ways. My MATLAB code is right, my hand calcs are right, like everything is in agreement. And so hopefully this code makes sense. It's a very easy tool to use. Again, you do have to pay for it. So if you don't want to pay for it and you still want to make a root locus, shoot over to my companion video on Python and I can show you how to do exactly the same thing in Python for free. Happy coding and hope this helped. Post in the comments if you have any questions.